what's called a LIFO data structure, last in, first out. In other words, you put items onto the stack, here's the first one, and then the next one goes on top, and then on top, and then on top, and the last item you placed onto the stack is the first one that you would take out. So fundamentally, that's the basics of a stack. Now this differs very much to the queue data structure, and you can think of this literally like a queue of people. This is a FIFO data structure, first in, first out. So the first item or person to come into the queue is at the front, and then the first person out is that person at the front. New items join the back of the queue. Okay, so let's just summarise them. So we've now drawn these in a slightly more useful way. We have a stack, and that's our LIFO data structure. The last item in is the first item out. And we have our queue, which is our FIFO data structure. The first item in is the first item out. Okay, so now we need to take this a little bit further and introduce you to some of the terminology and other common concepts associated with stacks and queues. So first of all, let's look at the queue. You'll notice here we have two arrows. Well, these are what we call pointers typically in programming. And if you're going to implement a queue data structure in code, you need to implement two pointers. We need a pointer for the front of the queue and a pointer for the back of the queue. At all times, your program must know, out of all the items in the queue, which one's the front and which one's the back. Because of course, when a new item joins the queue, it joins from the back of the queue. And when an item leaves the queue, it leaves from the front. So in this circumstance, if we had another item joining this queue, say that a number 18, it would join here at the back of the queue. And this pointer would then have to move here to say this was the back of the queue. If I wanted to get an item out of the queue, I would have to look at where the front pointer was, and it would be this value here which I would remove from the queue. And of course, having removed that item from the queue, my code would then have to decrement this pointer so it pointed to number 9 and said that that was at the front of the queue. When implementing a queue data structure, there's a number of things it has to be able to do. You have to be able to add items to a queue. They go in at the back. You have to be able to remove items from a queue. They come from the front. You have to be able to test if a queue is empty, and you also have to be able to test if a queue is full. As you'll see in the next video, there's also the concept of what we call linear queues, circular queues, and priority queues. But we'll go into what they are and the differences between them in the next video. Now let's switch back to the stack. In many ways it's very similar, but one of the big differences here is you notice we have just one pointer. We don't need to know where the back of the stack is, because a stack is the last item in is the first item out. All I need to know is what item is at the top of the stack. So I have one pointer, and it always points to the item at the top of the stack. Now there are several operations you need to be able to implement for a stack. Like before, you need to be able to add items to the stack. Now with stack, this is called pushing. So if I was going to add an item to this stack, I would push the value on. So let's say I was going to push the value 18, I would push it to the top of the stack, and my stack pointer would have to increase to go here. I also have to be able to remove items from the stack. Well, this is called popping. So pushing item adds to the stack and popping removes. To pop from the stack, I would take the value that's at the top, write it out, and then of course I would have to take this stack pointer and I'd have to decrease it so the top of the stack is now there. We also need to be able to peek, or sometimes this is referred to as top. The peek or top command simply looks at the item that's in the top of the stack, but doesn't actually remove it and decrement the stack pointer. And just like before with the queue, we have to be able to test if the stack is empty and test if the stack is full. So that's a basic introduction to stacks and queues and their main differences. In the next video, we'll look at them in some more detail.